Hello, welcome back. So today we're going to talk about area, volume, and average value. How do we calculate that with our calculus knowledge? First, area. So we know that the area under the curve above the x-axis between bounded by a and b, x equals to a and x equals to b, is going to be the integral from a to b fx and differentiate at x. So that would be the area of this shaded area. Okay, so what about the area between two curves, between two functions, such as, hey, I want you to find the area. So this is our fx function, and then I will have another one. This is g of x function, and I want you to find the area between these two functions from a to b, which is the highlighted part. It's going to be here. So that means instead of bounded by fx, x equals to a, x equals to b, and x, this is going to be bounded by fx, g of x equals to a, and x equals to b. So in this one, we can partitioning the interval from a to b and forming a Riemann sum, such as I can divide it or partitioning the area into 8 equal distance, and then 8 of them I'm going to have 8 or 7. Okay, maybe this one. 1, 2, 3, 4, 5. So this is 5 block. You can do as many as you want. And then the area should be the sum of these rectangles area. But how do we do it with an integral? So when it comes to integral, the area between two curves fx and g of x, where fx is above g of x for all of the x, the area is going to be from a to b, and then we use the area of x bounded by the x from x-axis, subtract the area of g of x dx. So basically, if you look at this graph, I can consider this part is equivalent to, I'm using the area of fx, which is this part, right? The red part we define as fx dx from a to b, and subtracting from a to b g of x, which is the blue part, right? So that will give us the in-between part, the area between these two curves. So when I combine these two together, I will have from a to b fx minus g of x minus, not subtract. Okay, so now what if, so now we are on the case that, hey, fx is above g of x. So that means fx is always greater than g of x for all of us. But what if we are in this situation? Well, this is our fx function, and this is our g of x function. And I want you to find the area from a to b. So in this part, we need to separate this into two regions. One region is when fx is above g of x, which is this part 1, or part A. And then the second part is when g of x is above fx. So let's say this is our part B. So the area of this region, the total area, so equals to the area from A plus the area from B. So let's say this point is C. C is between A and B. So that we need to calculate that two differently. One is from A to C, we have fx subtract g of x. And then I need to add the area from B, which is from C to B, we have g of x subtract f of x. So remember that when you're doing this type of question, the first thing is you always starting with a graph. After that, you need to identify which graph is on top and which one is in the bottom. It's always the top one, the top graph, subtract the bottom graph to find the in-between area. And then sometimes we need to separate them into couple regions. So here's an example. So now I have two functions. The first one is fx equals to t plus 3. And the other function is g of x equals to t squared minus 4t plus 3. So in these two functions, I want you to find the area from x equals to 0 to x equals to 3. Okay, so when we're doing this function, again, the first thing to do is you want to start in with the graph. You need to know which part the graph is in the top and which part the graph is on the bottom, because sometimes they will change their position. Well, if you don't know how to graph it, just use a graphing calculator or Desmos, which is online free graphing calculator. So first I will put on the function y equals to x plus 3, and the other one is x squared minus 4x plus 3. So as you can see, we are trying to find the area from 0 to 3. So in between this area, the function, the green line, is always above the line, above the parabola line. So that means when we set up the function, it should be integral from 0 to 3. I have fx subtract g of x, differentiate at x. So I have fx is t plus 3 minus, put the parentheses, because when you minus, you're going to change the sign inside of the function. Okay, so minus t squared minus 4t plus 3, and then differentiate at x, or t in this place. T or x, it doesn't matter. It just, as long as you keep it consistent, you know that, hey, this is the variable that we're trying to differentiate, then you will be good. And so when we simplify it, I have 5t minus t squared, differentiate at t. So now we can calculate that. So antiderivative, 5t, I got 5t squared minus 1/3 t to the cube from 0 to 3. So when you calculate that, I got 13.5. So that will be the area in between the curve fx and g of x. We're going to talk about volume. So volume. So when it comes to volume, let's think about the regular shape of volume, such as prism. How do you find the volume of prism? Well, we know that it's going to be the length times the width times the height. So what does that mean? That means you basically is use this area and times the height. So think about this stack. Well, if I just have one piece of the surface, just one surfaces, so that would be the area of these surfaces. If I'm trying to find the volume of this stack, what I do is I'm just adding all of their height together. So they're stacking together the sum of this height. The area of this one is going to give you the volume, right? This is similar to a cylinder. If you have a cylinder, how do you find the volume of a cylinder? It's going to be the area of the bottom of the circle, which is pi r squared, and times the height of the cylinder. That gives you the volume of the cylinder. So when we have some solid that is not a regular shape, how do we find the volume? So look at this solid. So this is like a really look like a cone, but it's not really. So I know that if I put a x-axis in the center of the solid, like what we show on the left of the graph, so and then we have a cross section and cut into half, we will get to a graph of what we see on the left. So this is the cross section of this shape. So basically is you rotated that about the x-axis, then you will get the solid to the left, right? So that means if I get the area of each one and then stacking together, then I will get the volume of this solid. So now let's think about it. I have this curve, right? And now I need to find the area of this circle. Let me draw a nicer one, which is this is our R. Let's say this is the radius. And now they have a multiple of this circle. Sometimes this is the R1, and then now I have another R in here, R2, each of these R is come from the curve, right? It's going to be the y-axis of the curve, and there are multiple of this circle. When they stack in together, again, they will going to form this solid. So for each of this one, I know that the area of this circle is equal to pi r squared, R1, and for this one it's going to pi r, R2 squared. And now we have a multiple one. So that means the sum of this r squared is going to be the area of this curve, bounded by the curve, and from 0 to a, and then x-axis, right? So that means the volume of this solid is going to be pi times the area of this shading part square, because the area is equal to pi r squared, and then we just sum them up together. So the area is equal to what? So the area of this part is going to be our integral from a to b, and then fx at differentiate at x. Don't forget the square. So here is the formula for the volume of a solid obtained by rotating about x-axis. So this is going to be from a to b, pi times fx square d of x, differentiate of x. For example, I want you to find the volume of the solid formed by rotating the area under fx equals to e to the negative x on the interval from 0 to 1. So, and above the x-axis. So what will be the volume? So the volume is going to be from 0 to 1 pi times this function e negative x squared differentiated at x. So now let's calculate that. So pi is just a constant number equals to 3.14 blah blah blah. So I can just pull out the pi out and then now differentiate e to the negative 2x at dx. So to differentiate this part, you can use u substitution or integral by parts. So now let's use u substitution. I can let u equals to negative 2x, so that means du dx is equals to negative 2. So du is equals to, dx. So we want to get dx is equals to du over negative 2. So now I can use the u substitution. Substitute u equals to negative 2x and the dx equals to du over negative 2. So the pi from 0 to 1 e to the u times negative 1/2 at du. Again, I can pull the negative 1/2 out, so I got negative pi over 2 from 1 to 0 e to the u power du. So this is equals to negative pi over 2 eu from 0 to 1. Now I need to substitute u equals to negative 2x back to calculate what is the volume. So I have a u negative 2x from 0 to 1. So then you can put in a calculator to calculate that for you. So I have negative pi half e negative 2 minus e to the 0. And now let's use a calculator to calculate that. So for this one, I got negative 3.14, which is our pi, divided by 2, and then multiply e to the negative 2 power and then subtract e to the 0, which is 1. Okay, so this is equals to 1.358. And then whatever that unit it is. So the volume of this cylinder is equals to 1.358. So now the next part of this section is how do we find the average value from the integral. So the average value of a function fx on the integral from a to b is defined by 1 over b minus a, and then the area from a to b differentiate at fx. Such as I'm giving you a curve. I'm going to give you a curve that fx equals to 5 times square root of x. And I want you to find the average value of this curve. So what you're going to do is from 0 to 9. So for this one is we're using the formula. Let me move this away. We're using the formula from 0 to 9. So I let a equals to 0, b is equal to 9. So the average value is going to be 9 subtract 0. From 0 to 8, 5 plus square root of x, which is x to the 1/2 power, differentiate x. Okay, so I have 1/9 times the differentiating here, which is equals to 5 times x plus 2/3 of x over 3/2. And then from 0 to 9. And then when we simplify it, I got 1/9, 5 times 9 plus 2/3, 9 to the 3/2 power. And you can calculate that by calculator. So sometimes the problem is giving you a graph and want you to find the average of this area. So in our previous, I know that, hey, the integral is defined by, let's say, from a to b is from 0 to 8. And then in this part, I have a multiple section of Riemann integral. And I know that, hey, each one of these, okay, maybe this is not the most nicest graph. Let's do something more exaggerate. Still too flat. Let's do this one. So the total area of this Riemann integral is going to be the area of these 4 small rectangle, right? Let's say this is from 1 to 5. And then the area of each one of these, let's say the first one is 2, the area of the second one is 2.2, the third one is 2.4, and the fifth one is 3. And how do I find the average value in the past these 4 sections? So what you can do is you can just add the total area first, which is by the Riemann sum. I know that the total area is going to be 2 plus 2.3 plus 2.4 plus 3. Okay, so that is going to be from 1 to 5. That would be the area of this region, right? The bounded area. And now I want to find the average value. So this part is equals to 9.6. And now I want to find the average value of each block. What you can do is you can use what we learned earlier from 1 to 5 fx at dx. So that means the area is going to be 1/4 times 9.6, which is 2.8. So on average, each one of these block, 2.4, sorry. Each one of this block is equals to 2.4 and whatever unit it is. Okay, so let's recap this. In this chapter, we learned 3 things. The first thing is, how do we find the area in between the 2 curves? So we're going to use the upper curve. We're going to use the upper curve, subtract the lower curve, and find the integral of that. Sometimes we need to divide it into multiple parts, like this one. We need to divide it into part A and part B. And then for volume, we have our volume formula. We know that the volume is formed by multiple circles. And then what we do is just stacking this circle together. So here is our volume formula, which is V is equals to integral from A to B pi times r squared. And our r is going to be the area of the integral part. And then the last part is the average value. Is we taking the average value from A to B is going to be the area times 1 over A, the difference between B to A, or the distance between B to A. So that's it for today's video. Let me know if you have other questions. See you next time.